All right, ladies and gentlemen, the end of the trig unit is getting near. Last quiz before we start getting ready for the part 2 test. So here we go. Let's get on to this. All right, exact values. We've been playing with these for a while. Biggest thing to remember here, there's two things. Number one, we got to be able to keep straight what functions go with which functions. And we get the additional little play here of which quadrant am I in? 90, 180, 270, 360. I'm over here in the cosine quadrant. So I need to keep that in mind. Find the exact value of cosecant if sine is negative 18 over 19. If you really stop on this one and take a moment to think, cosecant and sines are just inverses. So cosecant would just be the inverse of sine, and again, it's not cosine. That's it. Are you going to be that nice in the quiz? Maybe. But even if I wasn't, again, all you would have to do, opposite over hypotenuse, cosecant is hypotenuse over opposite, and we talked about how you can use the Pythagorean theorem if you need a missing side. So we'll make a note of that. If there's a missing side, a squared plus b squared equals c squared. But c squared is always your hypotenuse. Those are always interchangeable. So we'll make that note, just in case we need it, but hopefully we won't. Okay. Simplify the expressions, show all work. 2 through 6, there is no equals. So you don't know where exactly you're ending, but again, you have your help sheet. Reminder again on help sheets. I will be walking around. If you have written on your help sheet, you need another one. Whether it's copying it off of there, getting one from me in class if I still have extras, but you cannot have extra writing on here. Just telling you in advance. Okay, let's get down to business here. So hopefully I can keep this on here as we go. All right, simplify the expression. Tangent. Tangent is sine over cosine. Times cosecant, which is 1 over sine. Divided by, I hate vertical division, so I'm not going to do it. Secant is 1 over cosine. So, we're multiplying here. I don't need a common denominator. I'm free to do what I want. Well, not anything I want to do, but what happens if you divide something by itself? We kind of know already, but just in case, I'll go ahead. Be like, oh, it means I flip this. And I'm set. Okay? You even could have at this step said 1 because it's the same thing. But again, when you're showing me work, show work. Don't just be like, equals 1. Don't do it. Don't do it. When in doubt, show me another step. All right, let's keep rolling here. You're like, wait a minute, Hardy, isn't cosine minus cosine just 0 and the sine's just, the answer is just sine? No. These are kind of attached. I'm just saying. So when you're looking at this, here's the other thing I would tell you. So yeah, that is not cancelable. No. Could I pair these together? I don't know if that would help me. So here's a spin trick. We've talked before about factoring. Myself, I see both these terms have cosine. Because there's two separate terms here with the minus. I'm going to take a cosine out. And then here, since if I subtract sine over, 1 minus sine squared would be cosine squared. And then just add your exponents. Because if I try to multiply these together, I'm not going to get anywhere. Sine and cosine aren't going to cancel. And we talked about how these are together, so I can't just do cosine minus cosine and call it 0. That wouldn't work either. So that's where I have to get a little bit creative. Like, how do I know when you just got to mess with things? But you can't follow rules that you don't have. Okay? So, next one. 1 over secant. Okay, so 1 over secant, if I switch the position of these, 1 over cosine would equal secant would equal cosine. I'm going to leave this one alone because it's sine and cosine right now. So now, let's see here. If I distribute here, cosine times cosine would be cosine squared. When I come here, be careful. I'm multiplying those together, right? Now, if you wanted to write it out as sine squared theta, cosine theta over cosine theta, and then cancel, that's fine. But again, cosine plus sine is 1. Bam. So you notice so far, yeah, that one I had to think a little bit. The rest of these, not terrible. Okay? Not terrible. Sine, cosine, I'll put those over 1. Secant, 1 over cosine. And we're multiplying. Just cancel out the stuff you don't need. Have a nice time with it. Again, just knowing how to get some minor conversions, that's grouped together with sine squared and 1. To get it looking like this, I just subtract it over its cosine. Don't forget squared. Cosecant is 1 over sine squared. Cosecant squared, 1 over sine squared. You can square both sides. That is absolutely a legal mathematical function that you can use. Cosine squared over sine squared. Cosine over sine is cotangent. So this is cotangent squared. Okay, we're always just looking for the simplest when we're simplifying the expressions. But show as much as you can. But the next part where it says verify, remember, this is the part where now we pick a side to work with. And again, most of the time you have choices here on how you might want to go about this. Okay? Your call. I'm going to go ahead, I think I'm going to work this. Because with that being a fraction and the plus, I think that's going to be trickier. So let's find out if Hardy's right or this is a bad idea. Let me grab a pencil. Okay. 1 minus sine squared. This is like a pattern developing here. 1 minus sine squared is cosine squared. So 1 over cosine squared. All right. What am I trying to get to? I'm trying to get to tangent squared plus 1, which is secant squared. But I'm at cosine. Oh, wait a minute. Cosine is the inverse of secant. So 1 over cosine squared would be secant squared. And secant squared is tangent squared plus 1. Again, don't leave me gaps. The last step you show me has to be able to get me directly to here. No other middle steps, no subtracting, no multiplying, no doing anything like that. If you don't get it exactly there, you're going to lose points. So when in doubt, show me some more. Okay, that's definitely the easier side here. So let's see. Secant is 1 over cosine divided by sine. I'm just going to write this out. I don't want to change sign. Times cotangent is cosine over sine divided by cosecant, which is 1 over sine. All right, let's clean this up and hope a lot of this stuff just goes bye-bye. So 1 over cosine times 1 over sine cosine over sine times sine over 1. Okay, where are we at here? Okay, now here's where I got to be careful. That multiply in the middle, there's no adding. This whole big old thing is fair game. So while I might see that right away, I could keep canceling here, but let's say I don't notice that. And I'm like, all right, what do I got left? Multiply across the top, multiply across the bottom. That sine and cosine in the denominator, there's not a plus, there's no need for an LCD. I can absolutely whack those. And I forgot to even be looking for what I was trying to find. Cosecant. That's cosecant. 1 over sine. Flip sine is cosecant. So again, pay attention. Add and subtract can get to be a little bit of a stinker. It's true, but for the most part, that's not going to be bad whatsoever. All right. Let's keep rolling here. So, graph the function. Oh, using radians and hardy. Okay, so let's roll back through here again. So my A value is 2. My B value is 1/3. So my period is 2 pi divided by 1/3, which is the same as multiplying by 3 over 1. Okay, my period is 6 pi. So if you're just doing, single lines for each, whatever you're going to do, that's fine. But if you're kind of cranking this out, you're like, okay, I start at 0. I'm ending at 6 pi. What's in the middle? 3 pi. Middle of 0 and 6. Middle of 0 and 3 is 1.5, but we don't do 1.5. We do 3 halves. So 3 pi over 2, and another 3 pi over 2 would be 6 pi over 2, which is 3 pi. 9 pi over 2. And another 3 pi over 2, which would be 12 pi over 2 or 6 pi. So there's your 5 points. Again, if you smush them together, I don't care. If you're like, no, I'm going to go every other line here. The only time you really got to be careful is on phase shifts with these, if you're going to do this, because phase shifts literally will move the entire graph. But I didn't run into that here, so I'm really not worried about it. And then here my A value is 2, and I'm dealing with cosine. So we just multiply all of those by 2. 2, -2, 2, 0, -2, 0, 2. And again, working on the curves, And as long as this is very clear and so is this, nothing's left blank, that's fine for my ordered pairs. But if you're not going to do that, I need to see ordered pairs. Wow. Okay, one more. My A value is 4. I'm also going to be going up 2. That's my K value in front. And then over here, since my B value is 2, my period is 2 pi over 2 or pi. I did those in different colors because, again, how do the things connect? B and C, A and K all go together. So my period is pi. So 0 pi. Middle would be half pi, pi over 2. The middle of 0 and 1/2 is 1/4. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. No phase shifts again. So with no phase shift, we can kind of spread things out a little more. Again, I'm not going to say anything bad if you just use the first 4 points. That's fine. Now, this gets a little more interesting. So we got sine. Multiply always first, add always second. So do this first, do this second. So multiply by 4. and then add 2. And if it was negative, we would subtract. And reminder as well, when you're doing, you're like, okay, Hardy, now how are we supposed to do that? 2, 4, 6. Again, consistency. Your center line not only is good to draw in, lets me see you know what you're doing. Number 2, it's also going to let you know, oh yeah, when I'm doing sine, my graph will start at the center line. Normally that's 0. In this case, it's not. So there's good reason to put that center line in, even if I don't specifically ask for it. Get this in there. Again, not bad. Now this has been a little while. We did this before we took the last quiz in our packet. We started the packet a day early. So if you're trying to remember back to when did you do this, you're going to want to go back and look at 616. You're going to want to go back and look at the lesson for that. So write the equation for the graph. So reminder. And again, I'm just going to use sine here. This is true for cosine as well. So if we had all 4, it's going to look like that. So remember how we go back and we do this. It typically is easiest first to find where your center line is. So I go down as low as -2 and as high as 6. So if I find the middle of that is going to be at 2. So my center line, my k value is 2. My A, how far is it from the center line to the top or the center line to the min? 2 to get 6 is 4. We'll chat more about that 4 in a second here. So we've got that. Then I go a little further. I'm like, okay, now I got to start figuring out how this period thing works. To me, again, if you look that there's a shift, you could look at this as a cosine graph possibly, but I'm like, that's in the middle of the thing. I really don't want to deal with that. So if I start here at the axis and I look at this, that looks like a sine graph to me. A sine graph with a period of 6. So if my period is 6 pi, I didn't say that a minute ago, I need the b value. That p doesn't help me. So, period is 2 pi over b. And now it's my job to do the quick cross multiply and solve this. So 6 pi b equals 2 pi. If I divide both sides by 6 pi, my b value is going to be 1/3. Okay? And since I'm starting right at the axis, and that's a clean place to start, there is no phase shift, so I don't have to worry about c on this one. So let's get into this. Y equals k plus, that's a normal sine graph. Sine graphs normally go center max, center min, and back to center. So my a value is positive. We said it's a sine graph. And then there's my b. So you can either put x over 3, or if you don't like playing that game, and you're like the b value is 1/3, you can do this, that's fine. If you were going to do a phase shift, though, it looks like you'd be moving right 3 pi over 2, because you'd have to find that center point, and then you'd be trying to figure out your period between those, between 3 pi over 2 and, holy moly, 15 pi over 2, which is still going to be 6 pi, by the way. So you could go that route, but in this case, that's so straightforward, I'm not even thinking about trying to get cute with that. Okay? Last one. Let's play the game again. So I'm kind of looking, and I'm like, this one's a little trickier. You're like, that looks like it's about -1.5 and about -2.5. So it looks like the middle. Looks like the middle is at -2. So we're down 2 this time for our vertical shift. My A value, if it's at 2, I go up to -1.5 or down to -2.5. So it looks like my A value is 1/2. Again, we'll check that for sign here in a bit. And if I start at the axis, let's see if we're clean again. If I start at the axis, center, down, center, top, classic cosine graph. Nothing cute. Again, if you wanted to play the shift game, you could, but not only, it's moving in the opposite direction, so it'd be negative. You're going into these weird little tweener ones again. I wouldn't do that. Looks like cosine. Looks like my period is pi over 2 right there. So let's see here. 2 pi over b equals pi over 2. So pi b equals 4 pi. Divide by pi. So b is 4. And I should have everything I need. Because again, if I'm starting right at the axis, I don't have to play the phase shift game. And we want to keep this simple. So, I know some of you now are going to take that as a challenge, and you're going to purposefully do a phase shift when you go just to make you think. Okay, center line. That is a classic cosine graph. It did not go up and then down. Cosine normally looks like this. So 1/2 cosine 4x. Nothing cute. And that's it. Okay? So there's a little more of a spread of different things, but the size is not going to be an issue. At least it shouldn't be an issue as far as that goes. So that's about it. The quiz is a little longer. It's just a couple of extra questions here and there with your identities and your exact values. But other than that, you got it rolling here. So if you have questions, let me know. We'll see you next time.